Volume types. EBS provides different types of volumes. These can be SSD backed or hard disk drive backed. SSDs are very good for random I/O operations, whereas SDDs are better suited for sequential reads and writes. The first type is general purpose SSD or GP2. These are SSD backed. They provide single digit millisecond latencies. GP2 provides a baseline performance of 3 IOPS per gigabyte of provisioned storage, with a minimum of 100 IOPS and a maximum of 10,000 IOPS. For example, if you provision 100 GB of GP2 storage, then you'll get a baseline performance of 300 IOPS. Or if you provision, say, 1500 gigabytes, then the baseline performance would be 4500 IOPS. For 1 GB of provisioned storage, baseline performance will still be 100 because it cannot get less than this. GP2 also provides a capability called burst bucket, which works similar to savings account. For example, let's say you get a salary of 10,000 per month, but you do not use all the money for your monthly expenses. So you save it in a bank account. And later, if you plan to buy a car, which would need a lot more than monthly salary, you pull up the additional amount from savings account. Burst bucket works similarly. If your application do not consume EBS volumes baseline performance, then the unused IOPS would be stored in something called a burst bucket, which is similar to savings account. Maximum that can be saved in a burst bucket is 5.4 million IOPS. When application needs more performance than baseline, the additional IOPS can be drained from the burst bucket. Also, maximum burst bucket cannot exceed more than 3000 IOPS. Let's understand it better using a graph. This is the graph. On x-axis, you have time in seconds. On y-axis, you have IOPS. Let's say you have provisioned a storage of 500 gigabytes. That means your baseline performance would be 500 into 3 IOPS equal to 1500 IOPS. So this is your baseline performance, 1500 IOPS. Suppose this is how your usage is on a second basis. The orange line represents your EBS volumes IOPS usage by the application. Till 50th or 60th second, your application has not used its baseline performance. The blue portion is the one which is unused. So these IOPS have not been used for over 50 seconds now. Now what will happen in this case? All these unused IOPS would be stored in something called burst bucket, just like your savings account. You have not used these many IOPS for some period, so all these unused IOPS would be stored here. Suddenly, after some time, your application needs more I/O performance. So it is consuming more IOPS than baseline from this point onwards. In this case, as the application is exhausting baseline IOPS every second, additional IOPS would be provided from the burst bucket. Also, there's an upper limit of 3000 IOPS of maximum burst. So your application cannot go beyond 3000 IOPS. One more thing, you can get a maximum of 5.4 million IOPS in the burst bucket, which will give you enough capacity to burst for 30 minutes continuously at 3000 IOPS. What if, for example, you provision 1300 GB? Then your baseline performance itself would be 3900 IOPS, more than 3000 IOPS, which is the max burst performance. So in this case, concept of burst bucket will not play any role. Let's see how to provision a GP2 volume in the console. You can provision your EC2 volume in two ways. Once during the launch of the instance. In this add storage section, when you add a new volume, see, you'll get a volume type of EBS. And then you can provision, you can give the size here, and then you can choose the volume type. Volume type can be GP2 or any other volume types which we are yet to discuss. Look at the highlighted portion, how IOPS changes when you change the size. So if you provision a size of 200 GB, you should get a baseline performance of 600 IOPS. If you provision a volume of size 300 gigabytes, you should get a baseline performance of 900 IOPS. There's one more way to create a volume or provision an EBS volume. Go to EC2 dashboard, and here you will find Elastic Block Store. Under Elastic Block Store you have volumes. Click on volume and then click on create volume. While creating create volume, you can mention the volume type as general purpose SSD or any other volume types, and then you can provision the storage size. Notice at the highlighted portion again, it's similar to the previous one. If you change your provision size, your IOPS also changes. If my volume size is 400, I'll get a baseline performance of 1200 and a burstable performance of 3000. If I provision for 500, I'll get a baseline performance of 1500 and a burstable performance of 3000. If I provision for say 1200, then the burstable performance is gone. I'll get a baseline performance of 3600 IOPS. What about throughput in GP2 volumes? It does not mean that just because you have an SSD volume, your application cannot perform sequential I/O operations. In GP2, a maximum of 160 megabytes per second of throughput can be achieved if used for sequential reads and writes. The second type of volume is provisioned IOPS or IO1, which is SSD backed and is designed for mainly database workloads. Using IO1, IOPS can be explicitly mentioned and is not dependent on the volume size. You can mention 100 to 32,000 IOPS per volume. One thing to note though, maximum ratio of provisioned IOPS to volume size cannot be more than 50:1. That means if volume size is 100 GB, then provisioned IOPS cannot be more than 5000. Let's see it in the console. When you create a volume and choose the volume type to be provisioned IOPS, you can provide IOPS irrespective of your size. For example, if I choose the size to be 100 GB, I can mention 4000 as the provisioned IOPS. Unlike GP2, wherein for 100 GB of storage volume, I cannot have more than 300 IOPS. Here, IOPS and size are mutually exclusive. As I said, the ratio of IOPS to size cannot be more than 50:1. That means if your volume size is 100, you cannot provision more than 5000 IOPS. So if we mention as 6000, then it will give us an error saying that maximum ratio of 50:1 is permitted between IOPS and volume size. The maximum IOPS which you can provision is 32,000. The third type of volume is throughput optimized volumes or ST1. This is HDD backed storage volume and is good for sequential workloads such as data warehouse, log processing, batch jobs, etc. Performance is measured in terms of throughput rather than IOPS. Baseline performance is 40 megabytes per second per terabyte of provisioned storage. That means if the storage size is 3 terabyte, it will give a throughput performance of 120 megabytes per second. Minimum baseline performance is 20 megabytes per second and the maximum is 500 megabytes per second. ST1 also provides burstable capability. The concept is exactly similar to that of GP2. Burst performance can be from 250 megabytes per second to 500 MB per second. Finally, we have cold storage or cold SSD volumes or SC1. SC1 is also HDD backed storage volume with lesser baseline performance than that of ST1. Performance is measured in throughput. SC1 provides burstable capability as well. Baseline performance of SC1 volumes is 12 megabytes per second per terabyte of provisioned storage with a maximum of 192 megabytes per second. Burstable performance varies from 80 megabytes per second to 250 megabytes per second. Notice the highlighted area when we choose throughput optimized ST1. So if the size is say 1 terabyte, then the throughput is 40 megabytes per second. If we make it say 5 terabyte or 5120 gigabytes, then I get a throughput of 200 megabytes per second. Maximum being 500. And also maximum burstable performance is 500. Same is the case with SC1. If we choose SC1 and we mention a size of 1 terabyte, I should get a throughput of 12 megabytes per second. And if I change it to 2 terabyte, I should get a throughput of 24 megabytes per second. The maximum burstable performance is 160 megabytes per second, but maximum baseline performance can be 192 megabytes per second. This table will give you a fair amount of idea how size limit, maximum IOPS, maximum throughput, maximum burst performance change as per volume type. The maximum size is 16 terabyte for each type of volumes, but the minimum changes. For GP2 it's 1 gigabyte, for IO1 it's 4 gigabytes, for ST1 and SC1 minimum size has to be 500 gigabytes. The maximum IOPS and maximum throughput changes as per the volume type. Let us go ahead and create a volume from scratch and attach it to an EC2 instance, and let's see how EC2 instance uses the EBS volumes.